Good afternoon, good evening, good morning, depending where you are. Welcome to this session. Today I'm going to talk about IoT patterns. And my name is Tony Shan. I put my Twitter handle and the hashtag here in case you're interested in tweeting. You can use these. So here I outline today's session. We're going to talk about a few topics. We'll start with a quick look at the current state of IoT. Then we will drill down to the IoT puzzle. We highlight some challenges and barriers, pain points in this space. Then we'll introduce the pattern approach. How do we tackle that? We'll talk about a pattern model for IoT, followed by a catalog with different patterns in the IoT space. And at the last, I will talk about some of the examples in the IoT patterns. So if we look at the sort of like the evolution of the industry, you can see different waves. In this chart, you can see we started with the Industrial Revolution, the first wave around 1784. Then we have the second wave with the assembly line around kind of like 100 years later. And another 100 years passed, we were at the third wave with this PLC. And kind of the pace has been actually accelerate. Now we're at a stage for the fourth generation. Sometimes we call it Industry 4.0. And with that, you can see a lot of devices. This is a chart about the number of devices that are connected to the internet. So we are at the 27. We're going to enter the 2018. It's about 28 billion, moving on to 35 billion next year. But the projection is at the end of this decade, we will have 50 billion devices connected on the net. So there are tremendous amount of opportunities. In this chart, you can see in the IoT space, various investments on different areas for application development, hardware, system integration, storage, as well as the connectivity and security. It's a substantial growth through the years. We are right over here, but you can see in 3 years we reach this amount in this market. So IT is booming. This is a survey which shows about 77% of development teams, they are already doing active development to build an IoT solution, which is exciting. Also, about half of them, they anticipate the solutions in IoT they are building or integrating will generate immediate impacts by the end of the year. So you can see the excitement in the market. On the other hand, there are also some challenges in this space. And this is based on some study and reports. In fact, more than half of the companies, they are struggling with the IoT complexity. They try to figure out how they can deal with this in an effective way. Also, if we look at the different initiatives in the market, in fact, 2 out of 3 IoT projects failed or incompleted, and to some cases even completed. They cannot meet the deadlines. They went over budget, things like that. So the picture is not so promising given where we are in the IoT space. So we try to take a look at the IoT puzzle. What's going on? What's happening? So we start with some basics. What is IoT? I think probably, there are a lot of definitions in the market. So here I pulled the definition from Oxford Dictionary, which provide a very good representation about what we mean by Internet of Things. It's a development of Internet where the objects are connected and also they send information back and forth. It's a pretty good one. On the other hand, if we want to drill down, literally in this IoT space, we talk about the three major things. The first is devices. You can see there are different things we deal with, including the mobile devices you are using, the phones, smartphones. There are cameras, there are the smart lighting. There are different like playing the music, and now we have voice device like Alexa, Echo, or Google Home. So all these different types of devices that are key part, the cornerstone for IoT. The secondly is the connectivity. With these devices, we had this device like small meter, things like thermostat. They are there, but most of them literally are not connected, like the appliance in your home. Now, the connectivity is the important thing to get these connected through some kind of mechanism. We'll briefly talk about these things later. But once they get connected, we can capture the data, we can analyze data, and we can understand the data and learn from the data. And then, likewise, with the data, we can actually take some action, maybe push some actionable items back to these devices or to some other useful devices. But that action part is actually related to this, what I call super informatics. We have to analyze these data, make sense of it, correlate to them, and then apply the insights, intelligence to the right action. So why do we need to worry about IoT? This is another survey talking about what the perspectives people have for IoT. And you can see the expectations are the improvement in the quality of services, product, productivity, the asset productivity, reduced cost, materials and waste. So a variety of things. You can see a lot of benefits from the IoT. Where can we use it? It's a very big topic. As a matter of fact, there are different specific areas or verticals where IoT really can help. One example is what is called connected health. You can see different patient management, the health management, personal monitoring, a lot of pieces here. The second area is like a car. Almost everybody drives a car, and there are a lot of things associated with the car in terms of the safety, traffic, maintenance, and other kind of like a roadside assistant in case of breakdown or accidents. So all these things can be used. There are other areas. I'm not going to list all of them, but you can see there are a lot of things that IoT can be applicable. So I list a few use cases here. The first one is called the kind of like a smart prescription. So a patient takes a prescription and get the pills from drugstore. And oftentimes, they are busy or they didn't take pills as scheduled by the doctor. So this one actually, with the smart cap here, you can see, it actually send an alert if you don't take it on time. And if you already take it, it will remind you, oh, you just took that one half an hour ago. You're supposed to take it every 4 hours. So this really it's helpful. The next one is the Nest. You're probably familiar with this one. Nest was acquired by Google. So this actually help manage the appliance in a building and in your home. So it can dramatically, reduce up to 30% of electricity, which is great. The last one is the smart parking. If you live in a big city, you go to a restaurant in downtown on Friday evening. it's difficult to find a parking spot. So this application is very useful to help you find the open spot. Actually, with the navigation, it actually direct you. You don't need to circle around. It will give you, the best way. A lot of one-way roads, streets in typical downtown area. So this is very effectively to guide you and to minimize the traffic and also to speed up where you can get there. On the other hand, not every IoT solution is so friendly. Now, what about the timeline? When did it come? Actually, it had been a while. If you look at when the Internet of Things, that term started, it was 18 years ago by Kevin. And since then, quite a few things happened. You can see different devices, different like this one I just mentioned, different the toothpaste, the light bulb. This is most of things happening at home, and also for the personal wearables. This can track your exercise, track your heartbeat. So a lot of this kind of things happening. Also industrial-wise, there are different devices that are making this more smaller, less costly. As a matter of fact, it's cheaper and cheaper to make a connectivity happen on multiple things. Now, who is doing that? It's a very overwhelming. If you look at this chart, there are a lot of logos. Most of them you're familiar with. But this is keeping adding. So specifically, there are vendors in the vertical industry sectors about personal, the home, the car, and the enterprise, and also the industrial IoT over here. Then there are vendors that provide the horizontal platform, which is not specifically tailored to any individual domains sector. So they're dealing with the connectivity, dealing with the software, how do we interface, things like that. Then the bottom layer are the building blocks in terms of hardware we build for individual devices, also the gateway we build over there, and there's also software part in terms of mobile OS operating system or real-time operating system. For connectivity, there are different protocols used. And depending on you use radio or cellular, there are different telecom providers which enable that. So you can see it's very crowded in this space. Now, we kind of walk through the IoT, taking a look at some basics. What is it? Why do we need to worry about? Where can we use it? And who is doing IoT, right? The key is how we can deal with this kind of IoT situation. What kind of technology, what kind of approach we can take. Giving what I already talked about, very exciting, a lot of innovations, but on the other hand, a lot of challenges, barriers, and also the kind of a survey shows a lot of failures in IT projects. So in the space, there are a lot of challenges. This is research by HP, and they list some of the key challenges, specifically from security perspective. So you can see about some numbers: 6 out of 10 vulnerable user interface. 70% of these devices, they are deployed on the network and are not encrypted. So there are a lot of potential challenges and potential holes for the hackers to explore to take advantage of these things and do the bad things. So in this chart, I listed some barriers in these IoT initiatives. There are different heterogeneous architecture simply because you are dealing with different devices, different components, and the different sensors. All these are very heterogeneous. So that's why you have to deal with this kind of architecturally deal with different components in the space. A lot of applications are siloed. They are traditionally kind of like not connected, or in some specific medical devices. They are typically deployed in the clinics or hospitals. They are very, they have special needs for monitoring, for measurement, or lab equipment. But they are typically in very siloed applications, hardware, software, and deployed in specific areas. Platform-wise, there are no standard platforms. A lot of activities here, but most of them are disjointed. And in terms of packages, there are different SDKs. If you look at in the market, there's no standard in terms of what packages can we use, what kind of standard libraries we can apply. A lot of proprietary products from the vendors. Of course, the good thing is they build a lot of things, and they also expand a lot of traditional products, solutions into this space. But the openness is a big challenge here. And also, the technology changes so fast. Really, we have to kind of find a way to effectively keep pace with what's going on. In terms of the decision making, it's very difficult, challenging to look at this space and leverage what we already know, and with the maturing and evolving information or advancement in the space, and how do we combine these things to justify different options and make sound decisions. Complexity, because the IoT space, as well as the OT and IT, and this combined is not just traditional information technology. This is the information technology with the operation technology together, and it really brings the complexity here. Operational wise, it's hard because we are dealing with things. They are deployed in different environments. They have different connectivity from the range wise, from distance wise, from mechanism wise. So that's why we have to see how do we operate in this kind of environment with different latency or things like that, the constraints, and how do we deal with it. For example, some of the sensors are deployed in rural areas, like in the oil and the gas industry. There's things there, and how do we leverage the data? How do we collect the data in a remote way? And how do we use the data, analyze it, apply some intelligence back to the wheel? So there are a lot of this kind of challenges in terms of how do we efficiently operate. Then there are a lot of implementations which are good, but a lot of efforts a little fragmented. People just kind of try it out, and in some cases, people even say, "Yeah, let's fail fast." I'm all for it, fail fast. But the efforts, initiatives need to be coordinated, need to be a little bit well tuned. Otherwise, these kind of things that we have something, we did something, but a lot of waste. And in terms of integration, we talk about how do we have the interoperability? How do we deal with the kind of portability, compatibility among different platforms or products or standards or protocols? Right now, there are a lot of pain points there in terms of efficient, effective integration. Then the last one is it's not a single application. So in IoT space, whether it's a device or it's an endpoint for some gateway, it's starting to provide multi-application, multi-service kind of like capabilities, and in some cases even multi-protocol capabilities, and that's added the complexity for a single device or gateway or application or even its cloud native service. How do we handle this kind of complexity? Now, with these kind of like pain points or barriers, limitations, there are a lot of innovations. If you look at this chart, these are the numbers of IoT platforms in the market. And in this year, we have more 450, actually more than 450. It's around the end of the year. And also, this is just the vendors. Some vendors even have multiple IoT platforms in their portfolio. So you can see it's tremendously complex and overwhelming in the space. So with that one, the left hand does not know what the right hand is doing, right? Because, all these different things, you will have some, awkward situation like this. Now, how do we tackle this? So we kind of like advocate leverage pattern. So what is a pattern? A pattern is a recurring solution to a standard problem or a recurring problem in a specific context. So the IoT pattern is literally using the pattern approach in the IoT space. So there are two styles of IoT patterns. One is called atomic pattern, which literally specifying a solution or resolution to some particular requirements or design concerns or some design problem. The second style is called the compound patterns. A compound pattern literally is sort of like composite. So it leverages a set of atomic patterns and then address a little bit more complex or bigger or more aspects in terms of the problem domain. So I put some kind of value prop why patterns help. So one is using a pattern, we will have a standard way to describe what is the design and what is the requirement and how do we implement. So it provides a very good way to kind of like standards the description about the problem, about what do we need to worry about, about what are kind of solutions that are applicable in that kind of scenarios. The second thing is build a common vocabulary so people can use the same term, follow the same kind of like steps. And in that way, you can avoid a lot of traps because like we said before, a lot of complexity here and easily you will fall into some traps and pitfalls and got stuck. So here, using this kind of effective solutions and which are proven, so you can, sort of like, take a shortcut to the problem resolution. And certainly this is about the kind of reuse, right? Using the pattern and there's a direct application. The problems, the symptom, and the characteristics are exactly match, so you can apply it quickly. On the other hand, there are cases that if it's a large scale, you have to tweak a little bit. You have to customize, or you have to look at the pattern solution to see what parts can be used indirectly, particularly in the compound pattern, as I mentioned earlier. You need that part. The other one is the sort of like, look at these things to see what kind of design applicability, what kind of rationales, as I list over here, associated with this pattern. Because, it's not just look at, the problem and you have to do some root cause analysis about the problem. And you also have to do some trade-offs as needed to see if I can apply one or two or multiple patterns into a complex problem. And the patterns also capture some expert knowledge. These are the best practices, and some of these are lessons learned. So this really, give us something that is really good to apply, rather try to figure out everything from bottom up. And from communications perspective, patterns really help to facilitate different communications, different teams handover with design, with implementation, with the DevOps, with operation, to smooth the kind of like the communication and get a better understanding to avoid misunderstanding or ambiguity. Now, in the IoT pattern space, we kind of like create a structure. So we break down into three pieces. The first piece is called a category. Category consists of different perspectives for the IoT. The second piece we call area. This is basically the stages that are broken down in the IoT pipeline. The third piece we call a type. Literally, there are different kinds of IoT solutions. So let's take a look at the individual pieces. The first piece is catalog. So in catalog, we have 4 parts in catalog. The first one is literally the business perspective. So if we look at IoT, we want to understand the IoT use cases, user stories, what kind of business process involved in the IoT domain. Second one is called the application perspective. This look at the IoT solution from functional perspective. What does it do? What kind of capability it provides? And also the integration part. Because in IoT space, typically you are not going to own or build everything by yourself. You are part of the sort of the overall IoT ecosystem. So you will partner with other pieces in this IoT ecosystem, components, supply chain, things like that. And this is from that perspective. The third one is the technology part. So these are the building blocks. In other words, the technology realization, what the specific tools we are going to use, what the specific products we are going to use, whether it's open source or codes, commercial products to use. Then also, typically, we kind of like try to leverage a platform. In fact, if you deal with a complex IoT problem, most likely you will need a platform of platforms. The fourth part in this category is the service perspective. This is literally in the runtime. From operation perspective, when we get this up and running, what kind of service level agreement do we have? How do we interact with the users? How do we look at the security perspective? How do we scale the solutions? How do we monitor the performance? So this solution will run as designed as needed, as agreed upon in service level agreement. How do we scale out? So a lot of these kind of things are captured in this perspective. The second piece is area. We cover 4 parts in this piece. So one is sensing. As you can know, as I mentioned earlier, in the IoT space, devices are the cornerstone. So literally what devices do, they sense the data, they capture, sense the environment, sense whatever the situation we want to monitor, we want to capture, then get this raw data, capture it, collect it, then try to see, what kind of elements, whether it's the heat, temperature, whether it's the height of an object or the speed of a car, all these kind of different types of things. The second one is the connectivity, as we mentioned. These are the connection. Once these data collected, we need to find a way to transfer these data elements, sensor data or device data, or whatever the piece is, to the destination area, whether it can be cloud or some data store. Really depends on the situation. And the third one is the analysis. Here we basically, with this data collected, and maybe not only from one set of devices, maybe combining different pieces. We want to use these data chunks and analyze what's going on, what kind of things of our interest. So here's the processing this data, do some summation, aggregation, do some advanced analytics, do some statistical modeling, even apply some artificial intelligence to extract the data, to find insights, and which really guide the actionable items we need to deliver. So the fourth part in this piece is the delivery. Delivery can be, with this analysis, we want to send a summation to a human being. Or if it's smart enough, it actually can send the actionable data to whether the original device or to another set of device. Or it can send an alert. Let's we capture some information about a patient monitoring, and let's see it's diabetes monitoring. Then we send an alert to doctor. Looks like there's some red flags. Can you check? Or if it's smart enough, it can detect, with this kind of pattern, these things most likely will happen. And I have 90% of confidence based on other cases, this kind of historical things. And that will be even smarter than doctor, because when doctor get an alert, not only, the IoT solution find the red flags and potential risks, it also linked to the historical analysis and give doctor, very quantifiable kind of like evidence or kind of a case for the doctor to justify. So the third piece is called a type. Here we kind of like leverage the traditional way we group patterns. So if you look at the first Scanner 4, they had the 23 patterns designed in that famous work. They actually created called the creational, structural, and the behavioral. So I added one called the universal. So basically, leverage what they defined in terms of group these patterns. Then, as I said, I need to deal with composite pattern. So I added one category called universe, which is more compound patterns, which deal with kind of cross-cutting concerns and also multifaceted situation. So these are the way in this model we try to kind of like classify different patterns in a logical way. Now here's a 3D model. Literally we talk about the category and the area and the type. Then we kind of like break down into 3 dimensions. And in category, we break down into 4 business application technology service. Likewise here. So it's built a sort of like a cube to represent different patterns identified. And also kind of like in this way, we can correlate some of the pieces to build composite patterns. So on this slide, show you the slides of the cubes. So I'm not going to go over all these things, but give you some examples on that one. So if you look at the business slide, so that the business category, and here we have this type, and over here we have these areas. Then we put the different patterns into this different kind of like matrix cell. So for example, this is the value model. So from business perspective, to deliver an IoT solution, we need to identify the value model, which means, what kind of thing do we do for the end users? What kind of things do we do for our stakeholders? What kind of things do we do with our partners? So this really helps you to, from business perspective, what kind of things we need to worry about, what the value do we generate, what value do we add, and in this kind of chain. And that also linked to the business model, as I mentioned here, is highly tied with the value model. So you can create your business model in terms of what kind of charter, mission, and vision you do, and how do I serve my customer, what kind of key product services, and how do I make this profitable in your business model. So I'm not going to go over everything, but this just shows you we do kind of slice and dice, which is business slice, application, technology, and service. Then we put these different items into the cell, and this actually includes multiple things in each cell. So next I'm going to give you some examples. And here is from business perspective, we talk about IoT adoption for a particular organization. And there are multiple things, like I mentioned earlier, the value model, the business model. But one of the things we need to do is look at what IoT brings to the table for our organization. So this is what is called the SWOT analysis to find out what IoT can help me in my organization, whether it will help me reduce the cost, save the environment, drive innovations, or what kind of social impacts to the society, or in terms of the usage of my current products and service lines. And these are the weakness, because there's a security concerns, as we mentioned. How do we deal with massive data, 50 billion devices? How do we deal with that? And how do I invest, right? It's your business model. How do you monetize that? And how do you invest? And a lot of time, there's no roadmap to how do we get from where we are today to the next. So there are opportunities in a lot of areas for healthcare, for wearable, depending on which industry you are in. Tremendous opportunity, but there are also threats, right? We talk about security for the hacking, right? What are the people's expectations for your product or services? In terms of demand, sometimes you have to sort of advocate why this helps. So from there, you try to see what makes sense, right? If you identify very viable user stories, you need to prioritize different things. Here's the approach, how do you kind of build the business relevance, as well as, the cost benefit effectiveness. So another example here is in terms of interaction of these IoT solutions. So this is a more technical part. One is the RESTful API. We do a lot, but the RESTful API is sort of request response. Another type is doing the asynchronous, so it's event-driven part. And also with that one, kind of how do we bridge these two, right? With the resource planning, we can actually have a mix of these two. There are different things like observer. It is actually a pattern used in IoT to do kind of observable and observer. So it's more kind of triggering event processing, complex event processing. And there's a PubSub. You can use that mechanism for topics. If you do message driven, we can use broker, proxy, protocol bridge. These are the mechanisms we use to do some filtering, to do some kind of field gateway. So in case I have device that are not IP enabled, but leverage a proxy, I can connect that device to cloud without major change on that particular asset physically. There are other pieces about registration, discovery, and sleeping endpoint. The last part is about the digital twin. Literally, this is sort of like a new in this paradigm to represent a physical asset in a virtual environment. So, a quick summary. We talk about the current state of IoT. Then we drill down to the IoT puzzle in terms of what is it, why do we need to worry about, where can we use it, who is doing that, then which leads to how do we do it, right? We introduce the pattern approach. We talk about the pattern model, CAT, category, area, type. Then we drill down to kind of like a different aspects in each dimension. So we introduce the 3D model. And with the 3D model, we kind of do the slice and dice, show you from different view, right? You can see the catalog of different things. Then we kind of like talk up a couple of examples from the pattern catalog. So quick kind of like takeaway, where can you go from there? So today we just kind of like touch the tip of the iceberg because a lot of things. We started learning the IoT pattern model and some of the components like, category, area, and type. Then if you want to learn more, you can take the boot camps we have, and also we have hands-on workshops which dive deep to specifics. Another thing you can do is leverage a toolkit. We have a toolkit help practitioners to sort of like, because there are a lot of things over here to help you speed up, what you need to worry about. How do you link the patterns with the issues or the problems you are tackling? And how do you identify, or how do you qualify some of the patterns are applicable and what you need to do. So this is kind of like, the toolkit we build to help you speed ahead initiatives. And last but not least, we also provide the professional guide. So this can be applicable to the real problems or initiatives, depending on where you are at the early stage or at the later stage to do what's need to be done. And then, whether you already did some POC implementation or you're doing migrating, there are different things we can provide. So if IoT, this is sort of like a future of IoT, but there's actually a pattern you can recognize in this chart. So I put my email address here. It's mail@myname.com. If you have any questions, comments about today's presentation, feel free to email me. Or if you have any needs, anything you want to learn more, to understand more, or apply these patterns in your initiatives, feel free to email me and we can set time to talk further. If you have any questions, feel free to post here. Let me try to read this message from Sabrina's. Is any standard operation procedure pattern design IoT to transform traditional into each one? How to speed up? Okay, so it's a long paragraph. I'm not sure if other people can read this one, but I'm going to read the question part. This gentleman is from India. He's doing deep research on IoT, how to apply advanced technology with IoT to different areas like marketing, farming. He had the two-part question here. Part one, is there a standard operating procedure pattern for designing IoT to transform traditional industry into smart health, smart cities, smart everything, right? Second part of the question is, how do I speed up research in the right direction? So let me address the first one part. As of now, there's no standard way to do this transformation or migration. So we're talking about the traditional industry, whether it's telecom or financial or healthcare. there are a lot of these traditional industries here, and there are a lot of things already happening through the last few generations. Like we did the SOA service-oriented architecture, we did the microservices, we did the social, we did the cloud, right? We did the big data to do. There are a lot of things happening, and the good and the bad. Good side is all these industries are transformed. Smarter, better, faster, right? On the other hand, these technologies also left some scars, not kind of the silver bullets goes in and solve all the problems. So they kind of accumulated a lot of things here. Now we are at the stage, say, okay, how do we use IoT to further transform this into, like I said, smart healthcare. In other area, terms, people talk about connected. You may heard of like connected health, connected car, whatever, right? But I think it's from IoT perspective is another wave or another level to further help this industry to tackle the pain points they have, whether these are the cost, the productivity, the efficiency, time to the market, and customer expectations, all these things. So I think in general, we know IoT is moving these things to another level and tackle the traditional problems as well as the new problems brought up by these big data, cloud, all these things. So from approach perspective, I don't think there's a standard approach. There are some good ways or means you can leverage to do this one. And that's why, we kind of build these patterns. It will capture, what are the good practices. There are no best practice per se in the IoT space, even though there are some best practice accumulated in the past. So it's an evolving space to kind of like look at the different scenarios, look at the common themes, and look at some unique challenges in each individual sector. Then find a kind of like a routine to do these things, and then how we can transform this. There will be pains along the way, but how do we do this in an effective way? So I would say still, it's growing. It's a learning curve for everybody. And this pattern catalog model we are building is sort of like, to facilitate that transformation, to shorten the learning curve, to accumulate the good practice, best practice eventually, and to help with this transformation. Now that leads to the second part of your question is, how do I speed up? I would say, because there's no standard procedure, for you to speed up, I would say two parts. One is to get better understanding about the whole ecosystem, right? With the IoT, with the last few waves, and with the things that are coming. Because, for example, blockchain, right? Is it relevant? Absolutely. Now, how is it relevant? How deep, right? For example, artificial intelligence, deep learning, right? We cannot just do things in isolated mode. Let's say, I'm just do IoT. I just get these things connected. I just did make this a little bit smarter. Well, yeah, that's the short-term goals for IoT. But we have to look a little bit, right, long-term to see how these pieces will work together, right? I mentioned the puzzle, right? IoT is part of the puzzle. But there are other pieces. In other words, you have to look at this kind of like convergent way and to find a synergy between different pieces. Then second part, I would say, how do you speed up is, find some areas that really, it's a finite scope, right? We cannot boil the ocean. We find some areas based on, the research you did before or the group you're in your current organization or research group to see what kind of small pieces we can tackle. In other words, find some low-hanging fruits. There are a lot of difficulties here. There are a lot of moving parts here. There are a lot of ambiguity in this space. Find some sweet spots based on your past experience, the research you guys had in the past, then do something small. Then you can find oh, this is probably very much match your interest, your passion, or the research strengths you have, resource-wise, equipment, the data sets, all the stuff that apply to it. So hope that address your two-part question. But if you need more, definitely we can set offline. Second question is from Declan. Do you have online links where I can learn more about the patterns you mentioned? Yeah, if you can, I have my email. Drop me an email. I can point you to some information. Like I said, this is a very evolving space. A lot of things moving and very dynamic. We are also, kind of experiencing that, but I will point you to, depending on which specific areas you are interested in. It's very big, right? If you look at it, are you focused on, the business side? How do I operate? Or are you focused on what I need to build with applications, or what kind of business application I want to build, or what kind of user application I want to build? Or you want to do at a little bit horizontal, what kind of service we need to do, both, sort of like, operational and the DevOps kind of things, as well as, technology. Want to see, okay, what kind of platform I can use, or what kind of platform I can bundle them together, or whether should I go to cloud native platforms or some on-premise platform. So drop me a note, Declan. I'd be glad to kind of to understand what kind of more specific things you want, and we can go from there. I want to thank you for attending this one. Hope you get some things, learn some things, and it is exciting space. And I have my email. Send me your feedbacks, questions, comments, requirements. We can go from there. Once again, thank you for attending. Have a good conference.